Z-buffer method with example. The Z-buffer method, also known as the depth buffer method, is a widely used technique for performing visible surface detection in computer graphics. Here are some key points to consider when working with the Z-buffer method in computer graphics. The Z-buffer method maintains a depth map of the scene. The Z-buffer method maintains a depth map of the scene, with each pixel in the map representing the distance from the viewpoint to the closest object at that position in the scene. This depth map is used to determine which surfaces are visible and which are hidden from the viewpoint. The Z-buffer method uses a two-pass algorithm. The Z-buffer method typically uses a two-pass algorithm, with the first pass computing the depth values for each pixel in the scene, and the second pass rendering the image using the depth information to determine which surfaces are visible and which are hidden. The Z-buffer method is efficient and effective. The Z-buffer method is efficient and effective and is widely used in both hardware and software rendering systems. It can handle complex scenes with a large number of objects and provides accurate and stable results. Example: consider a scene with two overlapping objects, a cube and a sphere. If the cube is closer to the viewpoint than the sphere, the Z-buffer method would render the image so that the cube is visible in front of the sphere. The algorithm would work as follows. During the first pass, the depth values for each pixel in the scene would be computed and stored in the Z-buffer. During the second pass, the image would be rendered by comparing the depth values for each pixel with the values stored in the Z-buffer. If the depth value for a pixel is less than the value stored in the Z-buffer, the pixel is considered to be visible and its color is drawn. If the depth value for a pixel is greater than the value stored in the Z-buffer, the pixel is considered to be hidden and is not drawn. In this example, the Z-buffer method would correctly identify that the cube is in front of the sphere and would render the image so that the cube is visible in front of the sphere. Like, share, subscribe for more videos. Thank you for watching.